Hello, everybody. My name is Jill Brown. I'm from RTI International, representing our team as well as our collaborators at the University of Vermont. Our project is exploring how new flood guidance tools like the FIM will be interpreted, shared, and used to guide flood response and action at the community level. So, of course, there are a wide range of potential end users of these products, all the way from the emergency management community down to the general public and everybody in between, which is kind of our focus, is those in-between communities. So specifically, we're looking to better understand information sharing in three audiences: local officials and decision makers, so those who are responsible for flood planning and response; health and human service organizations like hospitals and shelters; and then community stakeholder organizations like business leaders and faith-based leaders. So our plan is to conduct focus groups within 4 to 6 communities who have experienced recent flooding, then broaden to a survey to really validate what we learn in those focus groups, and eventually in year 2 get to some design thinking workshops with these intermediary stakeholders to help inform future tools. Thank you.
Aloha. So Leah Bremer is not able to be here. I'm in Fenton. I'm the one at the bottom. So this is a project in Hawaii, and definitely initiated by, we are frequently being the vulnerable area for the flooding. In 2018, we were setting the national record of almost 50 inches in 24 hours at the north shore of Kauai, Waipa rain gauge. And since then, we have been definitely trying to tackle this flood issue, and including not just hydrologists, which myself, but also a lot of communities in serious concern. So this project specifically, we're trying to incorporate and understanding the perceptions of the community, their concern about the flood risk in their community-based perspective, as well as different kind of nature-based solution to mitigate those flood issues. So thank you. That's not me.
Oh, so this project is about defining nationally consistent coastal flood severity thresholds, so quite different than the previous ones. And so speaking of floods, we are all dealing with those thresholds, and so those thresholds mainly qualitatively have been identified by NOAA by minor, moderate, and major floods. And we know that there are limitations with these. First, quantifying them, those qualitative descriptions, and also they are gauge-based. So we have such information for points which are sufficiently well measured, monitored for flooding, and so developing those thresholds are going to be, and applying them to on-gauge basins and stretches of the coast have been difficult, and so advising for flooding and flooding severities have been an issue. So in 2018, NOAA developed this report looking into thresholds of various severities, especially for coastal systems, under minor, moderate, and major floods. If you look at those trends, those look like perfect fits, right? But basically, if you look into the issues, it's basically that those green dots, and if you look, these are issued above mean lower low water, and the independent variable is the greater tidal range. But if you really subtract that mean lower low water from the tidal range, which would be a more appropriate datum for flood measurement and for issuing floods above that threshold, which might mean higher high water, those would be those purple points, which the indices like NSE, KGE are going to be negative. So basically, there are some variabilities within those thresholds, which are not necessarily described well with the tidal range at those points. So the objective of this project is to propose a machine learning-based framework for developing nationally consistent coastal flood severity thresholds. And this threshold looks into non-extreme and extreme floods and tries to look into flooding under various, like univariate-driven and compound flooding, and considering various input features, which I'm not going to get into the details, of course. And so that algorithm, once developed, is going to help us develop a consistent, uniform distributed flooding threshold across along the stretch of the coast of the United States, and helps with monitoring the patterns of flooding, and so how we can projected flooding regime in the future. Thank you.
Hi, so we're starting a project with colleagues at the University of Vermont and Jefferson, University of Alabama, Mike Federoff, as well as our colleagues at the Office of Water Prediction, David Valley, and the Flood Inundation Map team to embark on something called audience segmentation. More or less means that we work with 3 different groups of people. We're working with technical water resource users. We're working with general public, very broadly defined, purposefully because these graphics are intended to be used by people who are non-technical experts, and indigenous communities to understand how they understand and interpret the flood inundation maps, how we can map that to visualization best practice, and how we can provide actionable real-time changes that can improve the visualizations of the flood inundation maps so that they are improved as they are getting rolled out to be able to be more accessible and usable. So how many of you all have actually seen the FIMs that have been rolled out? Or how many of you have played around with it? If you haven't, if your hand is not raised, what I want you to do is tomorrow, I want you to meet me at 1:30 in this room. I'm looking for 4 to 5 folks. We're going to focus group the recently released flood inundation maps, and I'm curious to see what you're able to find quickly, where you're running into trouble, so that we can do some of our initial data collection on these 10% rollout. So I'll meet you all back here 1:30 tomorrow to do a little bit of FIM testing.
The best way to explain this project is by an example. So assume that this is forecasted rainfall, and this is the true rainfall. Is this a good forecast? Well, it depends. It is a terrible forecast for this basin, right? It is also a bad forecast for this basin. But it is a pretty good forecast for this basin, because it really doesn't matter if the water is flowing from the right branch or from the left branch, it will come to the outlet approximately at the same time. So which means that flood forecasting skill, if you use QPF, is scale dependent. So in the project, we are going to explore those issues for the whole country over the last, few years. So thank you.
All right. Hi, everybody. I'm going to just give 2 quick notes. Number 1, if I was to put everybody's name who was part of the Summer Institute and made it a success on this slide, it would be completely full, because this is a big project. And I will say, too, that this project is kind of awkwardly positioned because we just wrapped up the 2023 Summer Institute, and we're already starting to think about the 2024 Summer Institute. There we go. Okay, so the Summer Institute is a long-standing partnership between the National Weather Service's Office of Water Prediction and CWASI. And for the first time ever in 2023, this partnership was facilitated by CIROH. This is a 7-week summer program. It's always held at the National Water Center and at the University of Alabama. And this past year, we brought together 23 graduate students from various academic backgrounds to tackle collaborative research projects that aim to advance the mission of the National Water Center, such as enhancing the next-gen framework. The Summer Institute traditionally empowers students in the water community to advance science through collaboration, professional development, and technical training. And this experience not only advances students' technical and research skills, but it also builds lasting friendships and professional networks. And you can just ask our over 180 Summer Institute alumni. So our ask to the CIROH community is twofold. First off, we would ask you to consider serving as a research theme leader or as a research mentor. It would be wonderful to engage the CIROH community in that. And secondly, please encourage your graduate students to participate. It's a wonderful opportunity and they could be part of this growing network. Thank you.
We thought 1 minute is too long, but we decided to divide the time. So but we'll stay in 1 minute. So, okay. So my name is Imad Habib, and I'm part of this project that's trying to support the education and workforce development mission of CIROH. And we've heard a lot of exciting talks today, projects, and you all emphasize the need to train your students to implement these projects. So that's why our project is trying to help here. We will be conducting a workshop and a hackathon to develop new teaching modules that address CIROH's needs and themes. And we'll be doing that using the How to Learn platform that our team developed over the recent years.
All right, and my name is Courtney DiVittorio, and I have participated in a past workshop, have integrated existing HydroLearn modules into my own teaching, and I'm now facilitating upcoming workshops. So we're recruiting 24 faculty members to develop 12 new modules, and we plan to have a 1 to 2 day in-person workshop followed by a 8-day virtual workshop. So please take a look at the flyers on your table. And if you want to stay informed and keep in touch about the logistics, you can scan the QR code and give us your contact information, or just talk to us. You can also talk to Deanna McKay from Kawasi and also David Tarboton from Utah State. So thank you all.